this is basically the goal. So our goal today is to obtain the vMX, the vSRX, and the vQFX from Juniper. I want to show you where to get these images, what you need to do in order to download these images, because that is something that, yeah, a lot of you seem to struggle with. So the process is actually very easy once you know how to do it. So I will cover that. We will then go ahead and upload the files to our EVE-NG server. For some of the files, we have to do a little conversion. So I will go over this, how to do it, and show you where to find the information on the EVE website. The good thing is everything related to the Juniper images has already been done. So you can save all the hassle and simply go to the EVE-NG website and find a detailed instruction how to convert these images. And you can even copy paste the commands that you need to use. So that's really, really easy. We will then go ahead and create a basic lab. So I will show you how to add these nodes to your lab, how to design the things in your EVE-NG, how to use the commit system, because EVE-NG also has a commit system. So especially if you're setting up your server, let's say an Active Directory or whatever type of server you have, and you try to do some sort of baselining because you need this server all the time starting from a certain point, then it makes sense to use this commit system. And yeah, last but not least, we will upload some custom icons to make the lab look a bit nicer. That will be especially handy for the community edition, because in the pro edition, we have something called the logical topologies that I will show you, where you simply don't need to look at the web UI itself, but basically can use your own drawing to use in EVE-NG. And then I will cover how to, modify the templates, how to change the values, but I won't cover the custom templates too much, because that is something that we will do in the third session. So today I will show you the default templates, how to change the values on these default templates. And in the next session, we will cover some more advanced topics like EVE clustering, sharing the load, creating our own templates. So let's start with the image fetching process. So basically, when you're starting to lab with Juniper, you will have 3 base images. These are the most common ones. Of course, there's also Abstra now, or Juno Space, or the virtual JATP. There are a ton of images that you can use, but most likely you will have the vMX, the vSRX, and the vQFX. And for those who are not familiar with the devices, the vMX is basically the router that we use. If you're coming from a Cisco world, the vSRX can be used either as a firewall. That is what the SRX is, but you can also change it to packet mode, so that you have very lightweight router, I would call it. And you have the vQFX, that is the data center switching line that has been virtualized. So if you're coming from an enterprise world, you're probably wondering, why isn't there a virtual EX? That still isn't a thing. So if we try to lab with switching technologies, we will use the vQFX for that. The first thing you need is an active Juniper account. So if you go to the Juniper website for these trial images, you need to create a Juniper account if you don't already have one. The good news is it can be created for free. So we will soon click on one of the links and I will show you how this process works. It's also very, very easy. And once you have it, you can download basically all the trial images that are available. Of course, you can also reach out to your Juniper partner or to your Juniper SE if there's a certain image that you don't have access to with the free account, and usually everyone is very helpful and will try to set you up for a trial. So for the vMX, I will also later share the slides. So this is basically the link that we can go to. That is the landing page for the vMX trial. And the vMX comes in a vMX bundle if you download it. So there's some conversion that we need to do and some renaming that we need to do. And that is explained in detail on the EVE-NG website. I will also show you that a little bit later. So basically all the steps that you need to do are described there in detail, so that you simply can follow these instructions in order to set up your vMX. For the vSRX, it's relatively easy. You simply go to the site, download it, and it already is in the so-called QCOW2 format. So you simply upload it and yeah, you're ready to use it. So no need for converting anything. Just rename the file. That is what I will show you today. And then you're good to go. And for the vQFX, that's also relatively easy because there is actually the vQFX and the vMX consist of two parts, the routing engine and the packet forwarding engine. And in order to use the device in EVE-NG, you need to deploy both of them and connect them via an internal link. And for the vQFX, the PFE simply needs to be renamed from QCOW to QCOW2, and that's it. So that's also relatively easy to set up. So let's go ahead and go to one of the websites. Then I will show you how easy it is to obtain these images. Yeah, and basically this is now the vMX landing page. So once we're on that page, we simply scroll down a bit and we can already see that it's basically 4 steps. The first is to register a Juniper account. So you would simply click on this register button here. And as you can see, it would now start the user registration process. You simply go through that process. There's a mail coming where you need to confirm that this email address should be used, and then you're basically good to go. The next step is selecting the vMX software. So once you have your account, you simply click on select vMX software and you will be guided to the download site. It will automatically go to the vMX eval page. You can select the version that you want to test. And what we need is the KVM package that's also described on the EVE website. But basically, since EVE is just a kind of GUI or an extension for the KVM, whenever you are trying to obtain images, even if they are not officially supported or listed, it's always the KVM image that you can start with. There is also the possibility to convert the ESXi image, but that's a little bit more complicated. So whenever you have the opportunity to download the KVM image, use it, and you're good to go. And once we have that, there is the third step in order to use everything. That is the 60-day unlimited bandwidth, everything that you want to do with it. And you simply click on the link and the key will be downloaded. So it's not behind a paywall or something. You can simply download it and then you can use this 60-day trial. And after the 60 days, that is something I will also show you, which is for a lab, the official procedure. You can simply reset the device or wipe it, as it's called in EVE, and then you have another 60 days. So for a lab environment, that's perfectly fine. Obviously, that's not for the production environment, but and the last one is installing the license key. So that is done with the request system license add command. So if you click on that, you will be guided to the documentation where it tells you how to manage these licenses and how to paste them. So again, relatively straightforward. You can simply copy paste the commands. Even if you have not worked with Juniper, it will show you everything that needs to be done, and it will also show you the output that is expected. So that is basically the first step that we need to do. We need to fetch these images in order to upload them to our EVE-NG server. So we've now obtained the images, we've downloaded them. They are downloaded to my laptop currently. So the next part that we need to do is we need to upload these files to our EVE-NG server and convert them if needed. So the main folder that we're working with is the opt-unet lab add-ons QEMU folder. That is the one where you will find all your images. There will be some, like the VPC images will already be there. So in order to start, you need to rename your devices to a certain format, the folders to a certain format. That is also explained on the EVE-NG website in detail. So if you follow the links from the slides, they will not only tell you how to convert the files, but also how to rename them. Basically, that's the naming scheme that EVE expects. So if you rename your folder to vQFX RE, it will show up as a routing engine for the vQFX. If you name it differently, it will not recognize this template, so you will not see your nodes. So it's important for the first part of the folder, I will show you that in just a minute, that you follow this naming schemes. That's the same for the files. There are two options or possibilities. The first one is called the virt.io.a, and the second one is called the HDA file. That also depends on the image. Basically, it's a driver that's telling the QEMU how to address the hard disk. So make also sure to follow that on the EVE website. I've tested everything in detail. Sometimes it looks like things are working, but yeah, stick with what is officially mentioned and provided. For most of the devices, if you start labbing, it will already be the virt.io.a, but there might be some older devices that still need this HDA file for some dependencies that are there. And like I said, there is a great selection of how-tos on the EVE website. So yeah, it will basically explain everything in detail. It will show you how to convert the images, and it will also show you how to rename the images. So let's go ahead and go to the website really quick. EVG.net. And if we go to the documentation part, there is our how-to selection. And as you can see, there are a ton of how-tos available. For some of them, there are even YouTube videos that exist. So yeah, let's say we wanted to add the vSRX 3.0. You simply click on the respective link, and then you will see, okay, this is the image name that EVE is expecting. This is the original file name that you will have. So it will even show you how the original file name would look like. So you can simply compare it. Obviously, the version number can change. But like I said, that is a very detailed explanation. It will tell you how to create the folders. And as I just showed you on that slide, we are in the QEMU folder. And if we try to add the vSRX, the folder format is called vSRX-ng- some name that you can make up. It makes sense to use the version number in order to recognize these images later. But like I said, if you're, for example, have a Windows server and this is your Active Directory, then you can rename it to Windows-Active Directory. And in EVE, you will see this name listed as Active Directory, and then you know, okay, if I select this image, the Active Directory has already been installed. This is basically the naming that you can play with, and that makes your life easier at the end of the day. And basically, it will cover all the steps, including the permission fix done at the end. That's also a classic thing that you might stumble upon. That is simply to ensure that all the EVE processes internally have the correct file permissions, especially if we're uploading files. A lot of things can go wrong. So in order to have all the nodes up and running, you need to fix the permissions at the end of your process, and then you can start adding the devices and yeah, basically start labbing. So let's go back to the slides. So like I said, this is everything there is documented. So it's really, really easy to add these devices. But we will soon do that live here so that you can see how you would do it, because some of you recently asked me, it's explained, but can you show it as an example? Of course I can, not a big deal. Since we can access our EVE server via SSH, we can simply use an STP client or whatever fits you. Some of you use FileZilla, some use WinSCP. I have mobile extern, so I have an embedded SCP client where I can simply upload these images. And like I said, this needs to be done for every version that you need. If you have different flavors, like you're always starting with the Windows Server 2022, and you want an Exchange server, an AD server, and a NAC server, you can simply copy the images once you've uploaded it once. But especially if you're using the Juniper lab and you have a lot of different versions and devices, obviously you need to upload them. You could theoretically start with base, vSRX, vMX, or whatever, and use the update file. That's not a problem. But the update package is for the installation on the devices. So what I've seen is some people try to use the update package as a baseline in Eve, and obviously Eve cannot handle this update package file. And even if you rename it, it will not know what to do because the base OS and everything is missing. So you can update devices in EveNG. That is possible. So if you're working on a migration scenario and you want to test to jump between different versions, as long as that is supported, you will find that in the documents. If that is supported or not, you can 100% do that on Eve. But like I said, you need to start at some point with the full package and not just the update package. And like I said, if you're using the commit system, you can name your devices accordingly. So I would recommend to start with the name that you want to achieve, then start up your image, change a couple of things, commit everything, and then you know, okay, once I select this image, I will always have this certain preparation that I've done before. For Juniper devices, it's also relatively easy, of course, to simply copy the config, start the device as a new device, and simply paste the config. But like I said, especially if you're introducing third-party devices like Windows servers or like a full-blown Juno space that you have set up, which takes quite some time, you might want to use this commit system in order to have a baseline and a starting point, especially if you need it in multiple labs. And if you're labbing for certification, you can obviously use the labs that are provided by the Juniper courses. You can simply go to your Eve, recreate everything. There are a ton of topologies on Twitter, on LinkedIn. I see them every day popping up. So start to recreate the scenarios that you see at work, start to communicate with others, start to share. There are so many folks out there willing to help if you're struggling with something. So especially if you're doing this for certification, it makes sense to use EveNG because it really gives you a great benefit and you can adapt really quick to changes that you have to do. I mentioned that in the last session when I started. Most of that was either done in ESX with a very hideous vSwitch way or in hardware, but especially if you're sharing this with a couple of colleagues, I mean, a lot of you guys will know that. All of a sudden, some links are missing or some interfaces went down because there is a different scenario that some other colleagues have tested. And this is where Eve really shines because it really helps you to overcome all these issues. And almost all features can be labbed with EveNG. There are some of them that will not work, like virtual chassis, for example, because a virtual chassis makes no sense. I still hope that at some point it gets integrated into the vQFX or basically a virtual lab EX so that we can test this stuff for our lightweight labs. But currently, that is the most that folks ask me all the time. The virtual chassis technology is something that we cannot lab currently in a virtual lab. No matter if you're using Eve GNS or whatever, it's simply not possible on the V devices. So, but besides that, when I started labbing for the JNCAE SEC, for example, I could do everything in EveNG because the vSRX was, if I remember correct, I think the vMX was first, but the vSRX really started this whole V devices thing and really improved over the years. So, all right. So what I've done in the background is I've uploaded the file that we have just downloaded. Come on. All right. So I will show that to you. But this is basically the mobile X term. Like I said, some of you use secure CRT. I also use that as well. But the convenient thing for this is it has an integrated SCP client. So what I've done here is I went to my Eve server via SSH, and then I have created a folder called uploads. And as you can see, I have downloaded the latest vSRX, and put it there. So this is basically where we can start from now. So just as the Eve website described, we start with the device. Let me actually bring it up again, because that is something that a lot of you ask me. So let's go to the how-to section and let's go to the Juniper vSRX. So as you can see, this was the file name that we had. So now we need to convert it in order for Eve to recognize it. So at first it says, okay, we are creating a directory, naming this vSRX ng. In my case, I will name it vSRX 3.0. There's a reason for it, because I've modified my templates a bit. That will be covered in the session 3. But basically, if you would start with the vSRX, you would simply follow the instructions and create this folder. So let's go ahead and do that. In my case, I will use 3.0 and I will name it commit test. You will later see why. And that is basically the folder now. So like I said, the template will match the folder name. So the template that I have created will match this vSRX 3.0, or in the case of the description here, the vSRX ng. And according to that, it will know, okay, this is the template for the vSRX that I have to apply with a certain number of CPUs, certain number of memory, with some CPU flag set. I can access it via telnet. We'll also show you that in the GUI in just a minute. But that basically tells Eve, how to handle this device. And as you can see, we simply have to move the file. So this is basically the downloaded file that we have. And like I said, it's already a QCOW2, as you can see. And in this case, the vSRX3 is, as mentioned before, a VirtIOA device. So we can simply move the file, load, and it's called Junos vSRX3 something. And we will move that into our folder. And let me make that a bit bigger. VirtIOA QCOW2. So if we now go to our folder, we will see that, okay, inside of the vSRX 3.0 commit test, we have our hard disk. So usually, like I said, let me go one step up and issue this LS. As you can see here, for all the different devices that I've uploaded, usually it makes sense to use the version number. So if you are adding that on the GUI, that you immediately know, okay, this is a vMX 18.2 R1, this is a vMX 21.1, so that you immediately know what device you're dealing with, what features to expect, maybe sometimes what bugs to expect, how to ship around them. So it makes sense to include the version number in your naming. But just for this test, I will simply name it commit test, because I want to show you the commit system, and that makes it a bit easier to see this. So what we've done is we have obtained the images, we've uploaded them to Eve, we have converted them. So the next thing is we need to create our basic lab. So we start with a blank canvas, so a new lab. I will show you in just a second how that works on the GUI. The idea is to start small and get bigger. So what I see people doing from time to time is they think of this huge lab that they want to build, and they want to do everything at the same time. And usually that results in a lot of frustration, because stuff all of a sudden doesn't work. So it makes sense to start with 2 or 3 devices, import them, create the lab, make them talk to each other. If that works, add more devices, make them talk to the old devices, and so on, and simply grow your lab instead of doing everything at the same time. because a lot of the stuff can get mixed up if you're trying to go for the all-in option at once. Also, what to consider is, and that is related to the power that your ETH server has, because at the end of the day, you share all these CPU cores with your virtual devices. So you also need to design your lab for things like startup times and delays. If you have 40, 50, 60 devices, it might make sense to use some delays so that they don't start up at the same time, overwhelming your CPU and making the boot up time like 20 coffee cans long. Maybe, yeah, a simple delay here and there will hugely benefit the performance of your server. So think about what you're doing, how resource hungry your devices are, because it also depends if you're just deploying a vSRX or a full-blown extra server. That makes a huge difference. One device known for these performance hits is the vQFX. It might take some time to boot up and load everything. Just give it the time and don't power up too many devices at once. If you are using that for everyday labbing, that is why I always recommend the Pro Edition. Besides all the other handy features that you will get something called the picture or the logical maps function. So you can upload a topology and work with that topology. So you don't, I will show you that in a minute. Like I mentioned, for some devices, you need to deploy two virtual parts. So the forwarding plane and the control plane. And especially if your labs get bigger and you have a lot of connections, things can look quite messy. So it's a good idea to use the logical maps feature in order to reduce everything and just, yeah, make it look more slick. You can also use the auto NAT feature that comes with the Pro to access your external devices. Of course, there are ways. I mean, we're in networking. You can always try to do the same with the Community Edition, but it involves a lot of tempering and a lot of try and error until you get everything the way you want it. So it's easier to go for the auto NAT, especially if you're starting with ETH and start from there on. And even if you have external devices, like let's say you have an Abstra server somewhere and you want to discover your V devices, that's also possible. That was mentioned in the last session. Take into account you might need another interface or another security zone, and think about what you want to do at the end of the day, as usual. So let's go ahead and start with a lab. So once we log into ETH, let me actually close this demo lab. Once you log into ETH, you will basically be at the root position. So, and as you can see in ETH, you have the ability not only to create labs, but also create folders. So you can make yourself a nice little folder structure in order to find the labs again. For this example, I'm going to I think it was inside the certification, Open Learning. And let's start with a new lab. So let's call this one Part 2 Demo. This is version 1. So you can even have a versioning system. If you're distributing these labs to maybe some colleagues, you can use the versioning system. So in case they import it, they immediately see, okay, is this the newest version of the lab with the newest images? You can put yourself in as the author of the lab. If you have the Pro Edition, you can decide on what satellite to run this on. So in this case, we only have one server, so it's the master instance. The default is any. But if you have a very, very big lab, like I said, clustering will be covered in the third session. It might make sense to load the lab or parts of the lab on a different satellite in order to share the load and make your lab way, way bigger and way more powerful by distributing the load. And then you can, of course, add a description. So let's say this is the Open Learning Part 2 ETH lab. We hit save. ETH will now basically start by creating this lab for us. So, and as you can see, this is basically where every lab starts. You have your blank canvas, and now we can start to add nodes and objects. So let's go ahead and click on Add Object Node. most of the devices, especially if you start with Eve, they will be grayed out. As you can see, this Eve server has a lot of things already loaded into it. And like I said, in my case, I'm not using the Juniper vSRX or vSRX Next Gen, but I have created a custom template for the 3.0. But as you can see, Eve recognized this because we started with vSRX 3.0. And you can see that my commit test has already been selected. So this is basically, there are all the versions that I have uploaded that match this vSRX 3.0 are now listed here and will be applied with these CPU settings, RAM settings, amount of interfaces, and so on and so on. You can select custom icons here. That makes your labs look like, a bit more slick, I would say, especially if you're using the community edition and you don't have the possibility to use the logical labs feature. You can upload a custom image here, also a very cool feature. And this is basically where you could already start to temper with things a little bit. So as you can see, for this template, the default is 2 CPUs, 4 gigs of RAM, and 6 interfaces. That will change depending on the type of hardware that you upload and the type of template that you use. Usually it's a good idea to stick with the default. For testing purposes, you can try to go below it, but be warned, if you go below a certain threshold, some features or the whole device might stop working. So especially if you're saying, okay, this is just a very, very lightweight lab, I want to go below the recommendation, be advised, some really weird side effects can happen. Also the same with the QEMU version. This is basically everything that is installed on the Eve server. Simply leave this at the default. It will work for you. Same with the architecture and the QEMU NICs. And the custom options, that is something that I will cover in the 3rd session, where we talk about CPU flags that you can use and stuff like that. If you have the Pro Edition, again, we have the possibility to run this device on a separate satellite. So like I said, if you have a very huge lab where you say, okay, the Abstrado space and the JATP should run on one satellite, my fabric with the vQFXs should run on a different satellite, and my firewalling should be done on the 3rd or 4th or 5th satellite, you can select that here and start from there on. Same with the console, just stick with the default. For the vSRX, this is done via Telnet. So as shown in the last session, you have 2 options to access the devices. One is called the native mode, where you simply click on it and it will open your local Telnet client. And the other is the HTML5 desktop, where it will open it in a new window in your browser, so you don't need a local client. And if we hit save now, we can see that this device has now been added to our Eve lab. So let's go ahead and start this one. And if I click on it, you can see that I have logged in with the HTML5. And now I don't even need a local client. Everything is working in my Google Chrome that I used here to open this. So this is basically now the vSRX starting up. And I use this because this very simply can show you in a couple of minutes how to use the commit system. So let's jump back to our presentation while it's loading. So we have created the basic lab, and the next thing that we want to do is to change something on our image and use the commit system. So like I mentioned, like Junos, EVE-NG has a commit system. So everything I change on my device, I can commit that to come back to this very point. Like I said, this is especially handy for Windows servers or for, let's say, NAC systems that you use in combination with your Juniper devices, because usually that involves a lot of thinking and a lot of pre-configuring before you can actually use that in a lab. So it makes sense to do that once and then set this as a baseline and start from there on. Think of it like a start point. And like I said, some examples are the domain controller, Exchange server, space, whatever comes to your mind. And the idea is that the next time you add this node, this is what we will also soon see, everything that we have set as the baseline will be there and all the changes are already in place. And that becomes especially handy if you're dealing with multiple labs. Maybe you're sharing this with a colleague, or maybe you have 2 or 3 labs in parallel where you need the same baseline. So that is a feature that is really, really great and helps a lot, especially if you're using it for everyday labs, or if you're labbing for a certain certification topic that you always know, okay, of course, with Juniper devices, we can simply copy and paste the config. That's relatively easy, I know that. But this is also something that we can do if we have devices like Abstra, where we start to set up things or set up interfaces and stuff, and always want to make sure that we're starting from this point. What I did before with the renaming, I named it to commit test. You can use a name that fits your needs, like 21.1 baseline or whatever comes to your mind. So it makes sense to rename this image to something meaningful to you, so that you immediately know, okay, if I select this, I have certain feature set enabled, or whatever comes to your mind. And if you have multiple baselines, you simply repeat this step. And like I said, if you're starting with a blank Windows server, you don't need to upload it 5 times. You upload it once. You can then simply copy it and then start baselining all these images and later simply commit them. How is the commit working? Well, in order to commit something, we need 3 things. We need a pod number. Most of you will use the admin, which is pod 0. Then we need the lab ID. That is something we can look up in the GUI, in the lab detailed section. And we need the node number of the device that we're currently editing. We will then simply go to the respective folder and issue the commit command. This can take some time depending on the size of your disk and depending on the type of hard disk that you use. So give it some time. Sometimes it takes a bit longer. But yeah, once that is done, you start from the point that you have basically committed. That's the whole idea. So let's go back to our session here. Is it already there? No, not yet. Still booting up. So we need to give it some time. So now that this vSRX has booted up, let's go ahead and log in. So as you know, the default, if you log in, you simply log in with root and you're on the shell. And if you type CLI, now you are on your Junos. So let's do a quick show version. And as you can see, it's the vSRX, it's the 21.4R1. And it's basically an out-of-the-box vSRX. So let's assume that we want to change this device, make a baseline, and then commit this so that we know every time we add a new commit test, this is exactly the device that we want to have. So let's go ahead and first set the root password. That is something that we always need. And something that we will immediately see. Host name, let's name it test. And that is just so that we can see that it will change if I add another device. So as you can see, this is now the commit test. So if I would go ahead and add another vSRX with the name of the image, the commit test, it would start from the very same point that this vSRX had. It would come out of the box, everything would be in the amnesiac mode, and I would need to do that over and over again. Obviously, this is now very simple, just changing the host name, but I hope you get the idea. So let's say this is the baseline that we want to do. So I'm now powering off the device. Always a good idea instead of just killing it. So let's power this thing off, and then we can grab some things here. So like I said, we need 3 things. First is the pod number. In my case, that's admin, so it will be the 0. If you have multiple users on your EVE, you can see that in the user management on your EVE server, the pod that has been assigned to this user. But in this case, it's the admin, so the pod is 0. The next would be the lab ID. So if you go to the site here and check the lab details, it will show you the lab ID. So that is something that we would write down or write something in our heads. And the last one is the node number. So if you right-click the node, you will see vSRX3. That's the name of the device. And here is basically the node number that we need. So in this case, it's relatively easy. We only have one device, so it's 1. But especially if you're having huge labs, that can be a number up to, I don't know, I think the biggest I've seen is 90 something, but I'm sure there are quite bigger labs than that. So that is basically the node number that we need. So let me try to share the slide again so that you see the command that we need to use. So like I said, we got the 3 things. We got the pod number, the lab ID, and the node number. So we're now going to our EVE server. Let me try to do it like this so that you can see the slide and my CLI. Hope that works and it's not too small on your Windows. Hope that's good. So let's go to opt-unit lab temp. The pod number is 0. Then the lab ID in my case is starting with DBF. Okay, and then I can simply use the tab and it will show me, since it's randomly generated, I don't think there will be any collision at all. So simply type the first 3 or 4 characters and then simply hit tab. So that's basically your lab number. Of course, you can also copy and paste. And in our case, it was device number 1. So, and as you can see, there are some files in here. There is our hard disk or our diff hard disk. So the next thing that we need to do is to commit the changes. So to simply follow the instructions, qemu in qemu mg commit bird.ioa. As you can see, this is quite fast now, especially if you have larger labs where a lot of things changed, where you start with a 2 or 3 or 400 gigabyte hard disks, because these type of images exist. This can take quite some time. So if it needs time, just be patient and wait for the process to finish. So, and now we have committed the device. So every time we add this device now, let's go ahead and do that. And add a new node, vSRX 3.0, still the commit test. Save. So let's do it, put it to the right side. As you can see, we have a new node now. So this is number 2. This is still our number 1 node. So this one has been altered, and this one is the one that has been committed. So let's start this one up. And while that is booting, I will tell you a bit about the things that we also can do, because it makes sense to use customized icons from time to time. Makes your topology look a bit nicer. I've seen some of you experimenting with it. I always love to see custom topologies on LinkedIn, Twitter, or wherever. Just makes labbing a bit more calm, let's say. The folder that you need is the opt-unit lab. That is always your base folder, and the HTML images icons is the one where you would upload your icons. The size varies. You can also experiment with the different sizes. Usually I'm sticking with 32 by 32 or 64 by 64 pixels. But again, upload a PNG image. Don't make the mistake and make it 1000 like 1200 pixels, because this will basically flood your whole lab. and then you only have one node that you can look at. So yeah, again, start small and then try to customize these to your liking. It also makes sense to simply go to the folder, just download one of the default icons, and then you can immediately see, okay, what's the size of this? Does it look nice? Do I need to make it bigger or smaller? And whenever you add or edit a node, you can select this customized icon. So that is something, especially if you have the same, let's say, server type of image, always sticking with this Windows image. Maybe you have an icon for an Active Directory, or one for an Exchange server, or one for your Abstract server. Because Abstract, last time I checked, the template wasn't in there yet. So if you create a custom template, it makes sense to create a custom Abstract icon and upload that, so that you immediately see, okay, if I select this, this is basically my Abstract server. And while the vSRX is still booting up, I'm just going on. So basically, we have now uploaded some icons. Actually, let me show you that really quick. So if I go ahead and edit one of the devices, I can say here that I want a different icon. So let's say this vSRX is now, what do we have here? Do we have a firewall icon here? Yes, a blue firewall icon. It's safe. And as you can see, the icon changed now. As long as the device is not started, it will always be grayed out. So if you upload some colorful icons, don't get scared. This is perfectly fine and normal. And once you start them up, you can see it here, they turn into the color that your icon originally has. And there is our new SRX. And as you can see, the host name is already there. And if we try to log in, it will ask us for a password, because we've committed this image, and this is now our new baseline image. So every time I'm adding the vSRX 3.0 now with the image of the commit test, this is where I'm starting. And you can do that with all types of devices. And like I said, if you name them accordingly, or name them like feature or a different version, it makes it way easier for you to see, okay, what type of device do I need? Well, like I said, some Active Directory server, or keep going back to that. I'm not sponsored by Microsoft, by the way, but that is something that I struggle with and I don't like to do over and over again. So that is where it mostly helps. And yeah, like I said, use a naming that fits your needs and makes it easier for you to recognize, and simply start from there on. When modifying templates, we are not just modifying the template for just one node, but for all the nodes in that respective template. So if I would start to temper around with the vSRX 3.0 template, that would affect all the images that I would upload with this respective folder name. So if you modify templates, be careful, especially, like I said, if you go below a certain threshold. It makes sense to just edit the node and experiment with that. But let's say you have a different type of CPU and you need to change some flags, for example. That is, again, something that I will cover in the next session. It makes sense to modify the template, or maybe create your own template. So yeah, there are basically two folders, and that depends on the type of hardware that you use. For the Intel-based devices, this is the OptUnetLab HTML templates Intel. And for AMD-based servers, this is the AMD folder. And like this guy said, if you mix them, you're going to have a bad time. Because if you're trying to give an Intel CPU AMD instructions, things will not work. Worst case, nothing will start at all. So always make sure to look into the folder that you have, into the right folder. And yeah, sometimes you, even if it's a shared server, you might need to look that up. But I think most of you, if you're using a bare metal server, know if you're having an Intel or an AMD CPU. So always make sure to be in the right template folder. Because let's say you have an Intel CPU and you modify the AMD template, then you will scream and shout because your changes are not reflected. Well, because you're editing the wrong template. So let's go into this templates folder. Unit lab HTML templates. In my case, it's Intel. So let me make this a bit bigger. So as you can see, there are a lot of templates already predefined. And what I did here is created the vSRX 3.0. And now you know why it's reacting to my folder name of vSRX 3.0, because this is where you basically link everything. If I go ahead and edit this, I can now change the default for all the devices in that category. So I could say, okay, I'm not using the flavor with the 2 CPUs and 4 gig RAM, but I'm using one with 8 CPUs and 16 gig RAM, or whatever fits your needs. But what I wanted to show you is that you can also change the naming of your interfaces. If I go to the Eve server again, let me bring that up. And I'm connecting the devices. You can see that they are named GE something. I could change that just for fun. Let's go ahead and rename it to Juniper 000. Save that. And now let's do that again. And all of a sudden, now my interfaces are called Juniper 000, and so on. Obviously, this does not make a lot of sense, because now you're wondering, okay, what is Juniper 000? But that gives you an idea, if you change something, how the system will react to that and how it reflects. And maybe you're using a template. Let's say the vEX comes out tomorrow and it's not GE but XE interfaces. Then you can simply go into the template, rename the GE to XE, and then you immediately know, okay, this is dealing with 10 gig devices, so with the XE interfaces. And actually, let's change that back, because if not, I will wonder, what have I done here next time? All right, and now we're back to the GE interfaces. Like I said, if you're doing this for labbing each and every day, okay, it's reflected. You can see one of the devices is powered on, one is powered off. If you have the community edition, adding another link would now not be possible, because adding links to an already running device is called a hot link add. That is a Eve Pro feature. And like I said, if you are using these devices and you have a lot of nodes and a huge topology with a lot of cross connects, things can look a bit messy. So this is what I also wanted to show you. Let me go into one of the labs that my fellow ambassador Chris Parker has created for us. I think it was in the ENT, in the OSPF section. Yes. This is a lab that Chris Parker created. So huge shout outs to Chris for coming up with these amazing topologies. And I mean, he's a teacher, he knows his stuff, obviously. But as you can see, I have vMXs here. So I need a forwarding plane and a control plane. So like I said, you need an internal link and things. Yeah, it just looks a bit messy. So what you could do with the Pro Edition is you can add a picture. And once you've done that, you will see on the left side that something called logical maps appeared. So if you click on these logical maps, you will see the picture that you have uploaded. And now this is a drawing that I did on my whiteboard. And now it's not looking, I mean, if you consider my drawing is not hideous, but it looks way cleaner, because now I don't have to deal with FPCs and VCPs and all that stuff. I simply have to deal with the routers and the router names. So if I click on that and I will hover over here with my mouse, you can see that the cursor is changing, because let me go to the edit screen. You can map your nodes to the parts of the image that you have just uploaded, so that the Eve knows, okay, if I'm clicking on, let's say, on the 0 of the area 0 backbone, let's say this is the Windows server that I want to add. And if I click on the 0, I want to get a VNC session to the Windows server. So I simply add that to my topology here. And again, if I name everything correctly, I don't even need the node ID, because the name would simply match. If I hit save now, and go to the topology again. As you can see, it changed, and if I click on it, I am now connected to my Windows server. And in the background, there can be 15, 16, whatever kind of connections. I am working with my logical maps, my logical topology, and I don't have to deal with all these links laying around like, okay, what was that link name again? And it makes things way, way easier. And that is something that I definitely wanted to show you. So especially if you're doing this each and every day, this is something to consider. And like I said, modify always with sanity and care. Don't go too low. I mentioned that on my talk, and I think it was 2019 in Las Vegas at the last Next Work before all this COVID thing happened. I was labbing IPv6 on the old vSRX on the Firefly, and it had, I think it was 4 gigs of RAM, and I slimmed it down to, I think, 1 gig. Thinking about that now, it was a miracle that it came up in the first place, but everything worked except IPv6. And I was troubleshooting that for 3 or 4 hours, banging my head against the wall, thinking, what the heck is wrong here? And then later realized, okay, I went too low on the resources. The daemon never could come up because it was running out of memory. So try to stick with the defaults that the EVE templates give you. This has been tested. This has been proven to be stable. Until you want to experiment, that is something that you can do, but expect weird side effects. So don't waste your time if you see some of these side effects with debugging them, because mostly it's because you've gone too low on the resources. And like I said, I will cover that in the next session. If you start with a new Juniper device, let's say you want to add Abstra or JATP or a new device that comes out tomorrow and you don't see it in the template list of EVE, start with a Linux template. Most of the stuff will work with the Linux template. Add and modify that to your need, and then you're good to go. And then you can even run things that are officially not listed, but they will still work. And it's the same with third-party images. As long as you have a KVM image, EVE will be able to run it. So what I did some time ago was a POC where the customer used a NAC solution from Aruba. I think it's called ClearPass. And I wanted to lab a Juniper lab with the vQFX and this ClearPass system. And it wasn't in there back then. So I simply created a Linux template, uploaded this ClearPass KVM, and then I could lab with my vQFX and this third-party system that wasn't even there in EVE back at the time. So that is so powerful, this template system. And I would love to see more of that in the future. So if any one of you has an idea, something that you don't see yet, you can also go to the GitHub repo. You will find the templates there. You can, add your ideas and basically upload and, share some of the templates that you have created that will benefit others, and that will make EVE even bigger and better.